This video is going to help you determine what shape a molecule is. And the first thing is, if you haven't gone to Canvas to see the little yellow sticky note with the flowchart I put on there, you need to go do that first and make sure you have that available, because that will help you determine the name of the shape. So then you want to take your central atom and put it in the middle. You're going to spread it out and make it as symmetrical as you can. And then you're going to go ahead and put your dots. So each fluorine has 7 valence electrons. And carbon has 4. Go ahead and connect them up and just double check that all of your dots have partners in case you need a double bond. And in this case we don't, because they all do have partners. And once you have your picture drawn, you're going to count the number of outside atoms. So ignore the central atom and go ahead and count the outside atoms and electron clouds if you have them, and I'll show you that on the next one. And for this one we have 4, and the prefix for 4 is tetra. So anytime you have 4 outside atoms on the central atom, it's called a tetrahedral shape. All right, let's do the next one. This time we have P in the middle. Spread out the hydrogens as much as you can, and let's go ahead and do the dots. Each hydrogen is 1, phosphorus is 5. We can connect these up, and now we have our shape. None of the dots are by themselves, they all have partners, so we know we don't need a double bond. And then what you're going to do is to count the number of outside atoms, but also you're going to look at this electron cloud. So first of all, the number of outside atoms here is 3. So if you look at that flow chart, 3, the prefix is tri, so it's either going to be trigonoplanar or trigonal pyramid. Then what you're going to do is look at the central atom to see if there are any extra dots, which there are in this case right here on top of the P. And so those dots are repelling, those are electrons, and they're repelling the hydrogens, which is going to push them down so that it looks kind of like a pyramid. So it's going to look like this with the dots on top. And that is called a trigonal pyramid. If it didn't have the dots on the P, then it would be planar. All right, for the next one, boron, that should be a 3. Boron goes in the middle. We have a fluorine on 3 sides. Let's go ahead and put the dots. And boron only has 3 valence electrons, so when you pair it up, it looks like this. And it looks like boron is not meeting the octet rule, and it's not. It has 6 valence electrons that it's sharing with all of the fluorines, 2 per fluorine. But boron is an exception to the rule. It only needs 6 valence electrons instead of 8. So it's okay that it doesn't have all 8 here. And just like before, we're going to count the number of outside atoms, and in this case we have 3. So it's either going to be trigonal pyramid or trigonal planar, because 3, the prefix is tri. Because there are no dots on the boron, this one is planar, so this one is flat on the table. For the next one we have water. We're going to put oxygen in the middle, hydrogen on each side, and let's go ahead and do the dots. Oxygen has 6, so when you come back for seconds, make sure you do it on the top and the bottom. This one is tricky because it looks like it's linear, because it looks like a straight line, and it's fine to draw it this way, but you're going to have to be able to visualize what this looks like in 3 dimensions. And in 3 dimensions, well, first of all, let's count how many outside atoms we have, and we have 2. So this is either going to be linear or bent. And because we have all of these clouds right here, this one is going to be bent. Those clouds are repelling those hydrogens and pushing them away. So if you remember, the farthest that 4 things can get from each other is the tetrahedral shape. So this is kind of what it looks like. But 2 of them are clouds, so you can't really see them. They're just clouds of negative charge. And so now you see how there's an angle between these 2 hydrogens. And that's why it's bent. It's because those clouds are repelling, they're pushing on those hydrogens and bending them down into that bent shape. So again, if you have 2 outside atoms, it's either linear or bent, and if it has dots in the middle, that means it's bent. All right, for this one, make sure you always put carbon in the middle. So think C4 center, and then spread everything else around the outside. That should also be a 2 right there. And we have 2 chlorines. We can go ahead and bond them up, And again, we have 4 outside atoms. Anytime you have 4, the prefix is tetra. All right, and this last one is diatomic fluorine. So when you draw the dots for this, it has 7. Pair them up. And then a lot of people get confused by this because they see all those dots on the fluorines and they try to say, well, maybe it's bent or something. But the thing is, if you only have 2 atoms total, then the only thing it can ever be is linear, because all you can do is draw a straight line between them. So the rule about the dots affecting the shape is only if they're on the central atom, and to be a central atom, it has to have 2 other atoms bonded to it, at least 2 other atoms. So there is no central atom in this case, and so all you can just do is draw a straight line between them. So regardless of if there's dots on them, it's just a linear shape. And hopefully that will help you draw the shapes for your progress check.